Okay, continuing on with our lesson for 0.2, we are going to investigate a couple more limits or verify them numerically. So always looking at the left side and then the right side, and I'm picking values that get closer and closer to our C value there. So if we're getting closer and closer to 4 from the left side, I'm going to start with 3.5 and then do 3.9 and 3.99. If I'm looking at the right side, I'm going to do 4.5, 4.1, and 4.01. And all I'm going to do is plug those into my calculator. So 3.5 squared, so forth and so on. And I get 12.25, 15.21, and 15.920. And again, all I'm doing is plugging those in and squaring them. When I plug in 4.5, I get 20.25. 5, not 2. I get 16.81. And I get 16.080. So you'll notice that these are getting closer and closer to 16. Again, left and right, and I get closer and closer to 0. So I'm going to do negative 0.5, negative 0.1, and negative 0.01. Sometimes you might want to do 0.1, 0.01, 0.0001. Up to you. 0.5, 0.1, 0.01. So when I plug those values in on the left side and do exponent, e to the exponent minus 1 over that number, I get 0.787. I get 0.9516. And I get 0.995. So you'll notice this is getting closer to 1. And then when I plug in 0.5, I get 1.297. When I plug in 0.1, I get 1.052, and then 1.005. So these are both getting closer and closer to 1. So we just verified numerically that the limit of e to the h minus 1 over h as h approaches 0 is 1. Okay, next one, investigating graphically and numerically. Let's go ahead and do numerically at first. So when I look at the left side, as x gets closer and closer to 0 from the left side, I'm going to do negative 0.1, negative 0.01, and negative 0.001. And on the right side, I'm going to do 0.1, 0.01, and 0.001. So we're going to go ahead and do that and see what we get. So if you take and plug all of these values into your calculators, you're going to get results that look like this. 0, 0, 0, 0, 0, 0. So let's go ahead and look at the graph again in Desmos. We are going to go ahead and type this in. So we're going to do sine of pi divided by x and hit enter. And you'll see here, this back and zoom in, that our function is oscillating back and forth. So it goes to 1, down to -1, and it begins oscillating more rapidly as we get closer and closer to 0. In this case, because it's oscillating back and forth so quickly, this limit does not exist. So what we usually do, and this is proper notation, you can use this anytime you need to, because we like to save time, we're going to say that it does not exist. Even though it looked like it was getting closer and closer to 0 numerically, that wasn't the truth on the graph. Okay, let's go on to number 6, or example 6. Actually, before example 6, we're going to look at one-sided limits. So everything that we talked about before is concerning what's happening on both sides. In some cases, one side might approach one value and the other side might approach another value. So what we're going to do is looking at limits from both sides. The left-handed limit, remember, has that negative after the c value or your value. The right-handed limit has a plus sign. And the limit itself, the two-sided limit exists if both one-sided limits exist and are the same. Okay, so what you're going to do is we are going to decide, investigating the one-sided limits, if the limit, the two-sided limit, exists. So this concept is still the same. If we look at the left side, and plug this in, going to 0, we're going to do negative 0.1, negative 0.01, and negative 0.001. So just get closer and closer there. Okay, and then do the same thing on the right side. So the limit as x approaches 0 from the right, we're going to do positive 0.1, 0.001, and 0.0001. So when I plug this in, if I plug in negative 0.1 divided by the absolute value of negative 0.1, I end up getting negative 1 for all three of these. If I plug in positives, I end up getting positive ones of all three of those. So the limit as x approaches 0 from the left side is negative 1, and the limit as x approaches 0 from the right side is positive 1. So the left-handed limit exists, the right-handed limit exists. However, the two-sided limit does not exist. Okay, this is a very common problem that you're going to investigate, and I'm going to get you started and try to consider what happens here. You need to compare, you need to look at the one-sided and two-sided limits at all values. So the limit as x approaches c from the left of the function, the limit as x approaches c from the right of the function, and then the two-sided limit. And you're going to do that for all of those. Okay, so we have 0, 2, and 4. So I'm going to go ahead and copy this if I can. And I'm going to paste it. So we'll do 0. And try to spread these out a little bit so they're easier to read. Okay, so what we're going to do is we're going to investigate all of these here. We're going to do 0, we're going to do 2, and we're going to do 4. So we'll do 2 from the left, 2 from the right, and two-sided, and 4 from the left, 4 from the right, and two-sided. Okay, so looking at this, as we approach 0 from the left side, what does this appear to be doing? Okay, notice it is oscillating like that previous graph we looked at, so I would say that this does not exist. However, if we go from the right side as we get closer and closer to 0, notice my graph is going towards 2. It doesn't have to be defined there, even if it is, as long as it's trending that way. So we would say that's 2. Now, the two-sided limit does not exist because this one doesn't exist. So therefore, those two can be equal. Next one, as we approach 2 from the left side, okay, so we get close to 2 from the left side, we are getting closer and closer to 3. As we approach 2 from the right side, we are getting closer and closer to 1. Okay, so I'm looking at this value here and this value here. So from the left side, we're going that way. From the right side, we're going that way. Doesn't matter if they're defined there, just if they're approaching it. Now, since those two exist, but they are not equal, this two-sided limit does not exist. Okay, and then the limit as x approaches 4. From the left side, it's getting closer and closer to 2. From the right side is getting closer and closer to 2. Since these both exist and they're the same, the two-sided limit is also 2. It does not matter that that does not exist there. Okay, last piece. Infinite limits. Sometimes they tend to infinity if it increases without bound. Those will have vertical asymptotes there. So when f of x approaches infinity or negative infinity, as x approaches c from one or both sides, it is called a vertical asymptote. So if we look at this graphically, I'm going to go ahead and flip over and type these in, what is happening as the limit approaches 2 from the left and the right of 1 over x minus 2? So let's go ahead and type that in. Okay, so notice on the left side, our graph is decreasing without bound, and from the right side, it is increasing without bound. So let's go ahead and write that down. So the limit as x approaches, 2 from the left of 1 over x minus 2 is negative infinity because it was going down without bound. Limit as x approaches 2 from the right of 1 over x minus 2 approaches positive infinity. I'm going to apologize there. It's been a while since I've written on this tablet. Hopefully you could read that okay. Make that a little bit smaller. So the next one then is 1 over x squared, and we're going to look at the left hand and right hand limit for that function. Okay, at 0. Notice these are both at 0, increasing without bound instead of decreasing without bound. So we are going to say that the limit as x approaches 0 from the left, put a pen here, zero from the left of 1 over x squared is infinity. The limit as x approaches 0 from the right of 1 over x squared is also infinity. Okay, this one we're looking at the right hand limit because it just has the plus sign there. So let's go ahead and type in the natural log of x. And as we approach 0 from the right side, so going across the graph towards the left, notice it's going to decrease without bound. So my limit there is actually negative infinity. Okay, so that's all we're doing for limits. I say that's all. There is actually more that we're doing for limits, but that's all we're doing for today. A lot of approximating, a lot of using graphs. Again, if you have any questions, please don't hesitate to ask. Have a great day.